Okay, here we go. We're graphing sine and cosine. Whoops. And cosine. Hopefully you guys are all still with me. Now today we're going to add our c value here. Uh-oh. Thank you for letting me know. I don't know who Jordan Williams is, though. Let's let them in again. Okay, so we have sine and cosine, and we are working with specifically letter C today. Thank you, Maddie, for letting me know that. And let's start graphing. Y is equal to, let's do 3 sine of x minus pi plus, let's do plus 1, just to make sure we can work on this. So we want to label our letters whenever we're working on this. We graph A is equal to, B is equal to, C is equal to, and D is equal to. And our standard form on the right side, Y is equal to A sine parentheses bx minus c plus d. Each of these letters stand for a characteristic of our graph, just like if you want to customize your own car or home. So what's our A? A is going to be our 3. B is the invisible 1. C is a positive pi because the negative is already here. And D is a positive 1. That's the only number left over. Okay, so these are the 4 characteristics that we use to graph any sine and cosine graph. And this creates our structure, and we draw our graph within that structure. We talked about how to graph this before. We start from right to left. So let's start with what we know, D. D is our vertical shift. If you don't remember, vertical shift. And the graph is moving up by plus 1. Think, I took the graph and I added plus 1 to it. That means the graph, which normally is over here, is moved up 1 space up. And we draw a D value across. Now this is our new horizontal axis. Jordan Williams, if you could give me your name so I can mark you present on the roster, that'd be great. Okay, and then we graph C. Now the problem with C is that we said C was my phase shift. It actually contributed to my phase shift. So our equation, we have a new equation just like period, x is equal to C over B. That means we just copy the letter C and we copy the letter B, and that is our starting point now, pi. Now we can mark that wherever we want. I'm gonna write it right here, and our new starting point of the graph will be right here. So the graph is gonna be pushed forward, and that's what we call a phase shift because it moves my graph either forward or backwards. It's almost like a delay at your dentist's office. Okay? If there are a lot of people taking a lot of time, it's gonna push back or push forward your appointment time. So let's say my appointment was here and we got shifted forward. Let's keep on going. Our B value is how long it takes me to finish my graph. B is our frequency. I'm gonna see this once in 2 pi. So instead we use P is equal to 2 pi over B, which is 2 pi. So here is what you need to be able to do. And you gotta be careful here, okay? Gotta be careful. If I start off at 1 o'clock and it takes me 2 hours to finish homework, when do I finish? I finished at 1 plus 2 is 3 o'clock. So if I start my graph at pi and I finish 2 pi later, that means I'm gonna finish at 3 pi. So here's what we do. We say, we start at pi plus period start plus the period equals to the end. I need to end at 3 pi. Now, I could write 3 pi here, and that will look totally crazy weird because we already took a pi. So I'm going to use that as my benchmark. So this is 1 pi, 2 pi, 3 pi. Here is 3 pi. Here's 2 pi. Now, as we always did our, thank you very much. That's fine. I just didn't know who that was. Sorry I kicked you out. That's fine. Okay, sorry. So if we start at pi, we end up at 3 pi. Now, with period, we always draw half, half, and half. So half between 1 and 3 is 2. If you're not sure, 1 plus 3 is 4. Divide by 2, that is 2. That's the halfway point there. Half, half, and half, you can draw the tick marks first. And if you want to work on the label, 1 plus 2 is 3. Half of that is 1.5, or 3 over 2 pi. What's halfway between 2 and 3? 2 plus 3 is 5. Divided by 2, 5 over 2. 5 pi over 2. Just label it. Now, it's important for us to practice this labeling. It's just a skill that we should know and not be afraid of. So then I copy onto my d value, half, half, and half. So if you look at my tick marks, these tick marks here are where the center of my graph is going to be now. We graph D, we graph C, we graph B, and now all we need is A. Now the A value is plus 3. So from my new D value, remember where the graph went up one space? We go up 1, 2, 3 up, and 1, 2, 3 down. Draw my dotted lines across the way. So the graph we know is going to fit someplace in between those two lines. Now, as a reminder, sine graphs go 0, up, 0, down, 0. That's what a sine graph does. So 0, up all the way to my first tick mark, all the way back down to 0 on my second tick mark, all the way down the graph to my third tick mark, and back to 0. You have to finish one full cycle in 2 pi. Now, you might say a couple of things that you might notice. Let's go over this graph one more time to make sure we got all the characteristics. Is your A value 3? 1, 2, 3. 1, 2, 3. Yes, it is. That's the full breadth of my graph. Is the frequency 1? Between 1 pi and 3 pi, that's 2 pi. How many times do you see the graph? You see exactly once. That's a frequency. That's a fast way of looking at it. What about the C value? C value was C over B. That said with pi, so we started at pi. And our D value is 1. And we are raised by 1. Yep, we have all the characteristics. Now, to finish the graph doesn't really start here. Remember, sine graphs keep on going? So what I'm going to do is I'm going to make sure I have this proportioned out correctly. From pi to 2 pi, right? From here to here. Wasn't that one loop? So as I go backwards, half, half, and half, I want to make sure I cover that one loop going backwards. Make that look nice, and this graph keeps on going. So you always have to draw it back to 0. Make sure you draw it back to 0. Okay, draw it back to 0. Don't just leave it hanging in midair. All right, let's continue this model. Now, does this change with cosine at all? And the answer is no. The only difference is if I write cosine, let me go ahead and erase some of this stuff here. If I write cosine of this model, if I write 3 cosine of x minus pi plus 1, the A is still 3, the B is still 1, the C is still pi, the D is still 1. All the characteristics are still the same, except for cosine, we start at the very top. Top, 0, down, 0, up. So please understand, the framework is still the same. It's just the starting point changes. Up, 0, down. This graph keeps on going. So look at the highlighter. This is my cosine graph, starting on the top amplitude, if it's a positive cosine. So let's make this a little more fluid so it's not as confusing. I am taking a lot of time doing this first problem, but let's go ahead and do another problem. Y is equal to 1/2 cosine of 2x. Actually, no, that's e raised to 1/2. Let's make this easy. I want you guys to see what effect the b value and the c value together have on the problem. Let me erase this also. Let's call this a negative. Make it easy, super easy. So let's look at our phase shift and how that is changing. A equals B equals C equals D equals. Please go ahead and take this moment, take 10 seconds to fill out A, B, C, and D. Hopefully it only takes you 5 or less. 1, 2, pi, 0. No D. C is in the parentheses. Now, let's go ahead and start setting up the graph. D is 0. Darn it, my line's all crooked. Okay, so we're going to be graphing at 0. Done. Check. Our C value, remember we have equation for this. X equals to C over B. So it's C over B, which is pi over 2. Now, I want to tell you honestly, this is why it's C over B. There are two ways of looking at it. First way is, look here. What would 2x minus pi be if you make it equal to 0? Add pi to both sides. Divide by 2. 2x equals to pi. Divide by 2. X equals to pi over 2. That's where we get that idea here. You could just make it 0 in your head, or you can remember C over B. That's really where it's from. Because we're trying to zero out our cosine. We know what the cosine of 0 is. It's going to be 1. It's going to be my amplitude. And that's where we start. We start when cosine, the unit circle, is 0. So we're trying to make it go back to 0. Okay, so pi over 2. I'm going to write pi over 2 right here. I don't know if that's a great place to put it. I'm going to put it here for now. And we're going to talk about why it's there. Let's talk about the next part here. 2 is my frequency, and that relates to period is 2 pi over 2 and is equal to pi. That means my graph normally should be at 2 pi. This is what a normal graph should look like. Darn it. But my period here is pi. So we have to finish everything by pi. Now, why is this important for us to see? Imagine if, you're doing chores at home and all of a sudden your mom says, Grandma's coming, hurry up, we gotta do everything faster. So you kick it up a notch. You gotta do the same work in the same short amount of time. Now, if I keep going with this graph, you notice that I can squeeze 2 of them in there now. And that's what frequency means. Frequency is 2 in 2 pi. So this 2 means I can squeeze 2 graphs in 2 pi. While if we look at period, is pi because it takes me pi to finish one graph. They're actually both the same meaning. They refer to the same instance, just reflecting on it from different views. It's like me saying half of my glass is half full or my glass is half empty. You guys heard of people saying that, right? Half full, half empty. It's the same thing. And we mentioned before, this is like a pharmacist saying, take these pills twice a day versus take these pills 1 every 12 hours. And I feel it's always easier when the pharmacist tells you how many hours to take the pills between. Take it once every 12 hours, no problem, I understand that. But if you tell me take twice a day, do you mean I can take it like 2 at the same time? Is that what you're telling me? 2 at the same time? Okay, I'm done. You tell your grandma, you ever try to tell your grandma how to take medicine? The doctor says take 2 in a day. And then she asks you 1,000 questions. What do you mean 2 a day? Do you mean for breakfast and lunch? What about dinner? Does she say, do I take them at the same time? But if the doctor says take it once every 12 hours, it's a lot more clear. And that's how I like looking at our graphs. Tell me it takes pi to finish. So I know I have to finish 1. And I can extrapolate that. I can go and say, hey, I have to draw 2 now in 2 pi. So let's go ahead and lay this out. So we need to draw a period of pi. If we start at pi over 2 plus, plus pi is what? 1 plus 50 cents is 150, or 3 over 2 pi. If you're not sure how to do that, we get a common denominator. Let me erase this, make it a little more clear. 2 pi over 2, right? 2 pi over 2, that's really 1 pi. 2 plus 1 is 3 over 2. So let's count. This is 1, 2, 3 pi over 2. Make sure I got those spaces about right. 3 pi over 2. And then we go half, half, and half. All right, so we did D, we did C, we did B. Now we just have to find the amplitude. Amplitude here is 1 space up, 1 space down. And I draw these bumper bowlers, right? I call them bumper bowling. Just make sure I know where the graph falls in between. Now, the last step here is, remember, this is a sine or cosine graph. And we see cosine, and cosine starts at the top. Let's put a dot at the top. Up, 0, down, 0, up. Up, 0, down, 0, up. And that is our cosine graph. Let's go ahead and draw the graph. Up, 0, down, 0, up. Does this graph stop? Nope, it keeps on going. If I continue to tick marks, this graph continues to keep on going. Now, by us adding C, it gives us a phase shift. And I need to keep reiterating this, that C isn't our stopping point. If our B value is 1, sure, C over B would be just C. But if it's C over anything, it's going to change it. Now, why does it change? It's because if you're not starting from 0, okay, let's go ahead and look at an example of a doctor's appointment again. Let's say you're the first person on the appointment line, right? Okay. If you go long on your appointment, does that bother you? No. What if you go short on your appointment? Does that bother you at all? No, that's your appointment time because you're the first person there. But what if you're the second person there? Okay. And there's someone before you, right? This is a graph. So what if I shrink the period? What if the period shrinks? What if the B value shrinks? If the B value shrinks, if their appointment is shorter, isn't your appointment pushed up? What if their appointment goes longer? Isn't your appointment pushed forward? And this is the idea. If C was, our starting point, our B value tells us how narrow or wide our graph is. So if our B value is super narrow, your C value is actually pulled forward and we start earlier. If your B value is extra wide, your C value is pushed forward right along with your B. So C isn't like D. D is great. We just take D for what it is, 0 or 1 or 2. But C, even though it's supposed to be our phase shift, our X value shift, it is always affected by the person before it, meaning that it shifts right along with it. And that's why the C is one of our most difficult values to graph. Because if we don't catch the person in front of me, you guys ever sit at a traffic light and the person in front of you is on their cell phone, right? Where everyone around you is going? You have to be paying attention to the person in front of you. And for us, that's the B period. Okay. All right, let's do one more. Y is equal to 1/2. I'm going to do a weird one. Sine of 3x minus pi over 2. This one is terrible. Mr. Go doesn't like us. Plus, let's say minus 1. Minus 1. Okay. A, B, C, D. Now, I want to tell you, this is one of the more difficult problems you will ever run into. And if you can manage to solve this problem, you got everything. You got 100% on everything. I'm telling you right now. If you can do this problem, you got 100% on everything. Because this problem's criminal. A, B, C, D. Go ahead and write down your A, B, C, D. Did you remember to just take the pi over 2, not the negative sign? Because in our original formula, a sine of bx minus c, the negative is already there. See, it's already there. How about the negative 1? Did you remember to take the negative 1 with you? Because it should be positive in my original. Let's go to graph it from D forward. D is negative 1. Oops, let me give myself some more space. Let me give myself a lot of space this time. Here's my negative 1. C, we don't graph C, right? We use it to find x. X equals to pi over 2 divided by 3. We don't like dividing fractions, so we multiply by the reciprocal. 3 over 1, that's the reciprocal of, oops, other way around, I messed up. 1 over 3. See, when I drew out my 3 over 1, I realized my mistake. And this is pi over 6. That's a weird number, but that's fine. Let's call this pi over 6 right here. Maybe I'll write it on top for more space. Pi over 6. Great, we know the graph is going to start here. Something like that. Our b value, which is 2 pi over b, which helps us find our period, 2 pi over 3. Oh my gosh, how am I supposed to write 2 pi over 3 here? Well, this is what I do. Just take your time and just write it on the side. I'm going to add the period to my starting value. My start, my period, equals to the end. You tell me when you start work, you tell me how many hours you're working, and I'll pick you up afterwards. Not me, but I'm talking about your parents. Okay, fractions are not the same, common denominator. Let's change this to a multiplied by 2, 4 over 6. Isn't 4 over 6 the same as 3 over 2? Yep. So we can say that's 6. So 5. So 4 plus 1 is 5 pi over 6. Let's count it. If this is 1, we can count more. 1, 2, 3, 4, 5. 5 pi over 6. Math, if anything, it makes you pay attention to details. Details are important. Half, half, and half. Oh, lucky for us. Half, half, and half. Oh my gosh. Like, these tick marks are just right. 2 pi over 3. Oh, 2 pi over 6 is pi over 3. 1, 2, 3 pi over 6 is pi over 2, reducing. 1, 2, 3, 4 pi over 6 is 2 pi over 3. Okay, so we can reduce a lot of these. Okay, copy the tick marks. 1, 2, 3, 4, 5. All these tick marks are being copied to my D value. We did D, we did C, we did B. Now all we have to do is A. And my A value is 1/2. So this is negative 1, half up, half down. We have to now fill in the graph. Is this a sine or cosine graph? Ask yourself, always ask yourself, is this a sine or cosine? Sine, and sine of 0 is 0. Please remember that. So it means we start off right in the middle. 0, up, 0, down, 0. 0, up, 0, down, 0. Oops, missed that one. And this graph continues in this trend over and over again. Now, from here to here, do we get one loop or is it just half? I want you guys to see if you guys can figure this out. Do I do one loop or just half? Well, isn't this one tick mark away? you don't see one full loop, you see just half. Okay, all right, that's it. So to get better at these graphs, you just have to keep practicing them, honestly. Like the more experience you have, the better, the faster you will graph this. Just like graphing slope-intercept form from Algebra 1, you eventually got better at it because of practice. And this, though it looks a lot more complicated, and it is, with practice, it just becomes DCBA, graphing one step at a time, not making any one part more difficult.